This is recitation 1, problem 3. For problem 3, we will have 3 charges, x and y coordinate system. We will have charge q1 that is located, q1 will be located at x0, y1. We will have charge q2, positive charge q2, that will be at point x2, y2, and we will have the third charge will be negative. It will be minus q3, and this charge q3 will be at point x3, y3. So now what we want to find the net force exerted on charge q2 by charges q1 and q3. So we are looking for the force exerted on charge q2 by charges q1 and q3. Let's draw these forces. The force exerted by charge q1 on q2 will be along this line, and it will be repulsive force. This is my force F1. The force exerted on q2 by q3 will be along this line, and it will be attractive force. Since q3 is negative, we will call it F3. And to find the net force, we need to add forces F1 and F3 as vectors. I remind you that we know what is the magnitude of the force between two charged particles. According to Coulomb's law, the force between two charged particles is coefficient K, and then Q1, magnitude of Q1, magnitude of Q2, divided by distance between them squared. So what we will do next, we will find F1, and we will express it in terms of components. Then we will find F3 in terms of components, and then we will add these two vectors. So what is F1, force F1 in terms of components? To find components of F1, I will draw a line that will be parallel to x. I need right triangle, so I'll draw a line perpendicular to x, and I will use this right triangle to find x and y components of F1. What is x component of F1? It will be this leg of this right triangle, and this vector is vector sum of this vector to the right and this vector that is up. So my x component is positive. Magnitude of this force F1 is K. Product of charges Q1, Q2, divided by distance between them squared. Distance between them is this length, but I will use this right triangle to find this length. This distance between these two charges is hypotenuse of this right triangle. So this distance squared is x2 squared plus y2 minus y1 squared, x2 squared plus y2 minus y1 squared. This is distance between these two charges squared. And then I need to multiply by some function of an angle. Let's introduce this angle. This angle, let's call it theta. It's angle with horizontal. And to find x component of F1, I need to multiply this hypotenuse by cosine theta. Cosine theta. This will be my Ix. We don't forget Ix. This is x component of F1. Y component of F1 is also positive. I put plus K, magnitude of force K, Q1, Q2 divided by distance between them squared, which is x2 squared plus y2 minus y1 squared. This is distance squared. And for y component, I need, this is y component, I need to multiply by sine theta. So I have sine theta Iy. Now we need to find what is cosine theta and sine theta in terms of what is given. I will use this right triangle because this is theta, then this angle is also theta. So I'll use this right triangle to find what is cosine theta. Cosine theta is this leg, adjacent leg, which is x2, divided by hypotenuse, which is x2 squared plus y2 minus y1 squared, y2 minus y1 squared. This is hypotenuse, square root. This is cosine theta and sine theta. Sine theta is opposite leg, which is y2 minus y1, y2 minus y1, divided by hypotenuse, which is square root of x2 squared plus y2 minus y1 squared. And the final expression for F1 is, now I bring cosine and sine theta back into my formula for F1. I have K, Q1, Q2, K, Q1, Q2, divided by x2 squared plus y2 minus y1 squared, times cosine theta, which brings x2 in the numerator, and then the same expression that I already have here. I have the same expression here to 1/2. 1 plus 1/2, 3/2. This is Ix. We don't forget Ix. This is my x component of F1, and then y component of F1 is K, Q1, Q2, divided by x2 squared plus y2 minus y1 squared. And sine theta is y2 minus y1. And then square root of x2 squared plus y2 minus y1 squared, 1 plus 1/2 brings me to 3/2. And we don't forget Iy. So this is my y component of force F1. Now we need to find F3. F3 is this force. I need to write F3 in terms of components. To do that, I will draw a line perpendicular to y, for example. This is my triangle that I will use to find components of F3. This vector is vector sum of these vectors and this vector. So we have x component of F3 positive. We put K, and then product of magnitudes of these charges, Q2, magnitude of Q3, divided by distance between them squared. What is the distance between them squared? I need different color. Let's use blue. This is the distance between them squared. This distance I will find by using this right triangle. This is 90 degrees. So this distance is this leg, which is x3 minus x2. x3 minus x2 squared plus this leg, which is y2 minus y3. y2 minus y3 squared. This is distance squared. To have x component, I need to introduce angle. Which angle will we introduce? Let's introduce again angle with horizontal. Let's call it phi. This angle is the same as this angle phi, but first of all, to have x component, I need to multiply by cosine phi here. Cosine phi. And this will be my x component. I multiplied by ix to show the direction. Y component is negative, so we put minus here. And then k, product of charges q2, q3, divided by distance between them squared, is distance is x3 minus x2 squared plus y2 minus y3 squared. Let's check, is that right? So I have distance squared, which is this leg, x3 minus x2 squared, and y2 minus y3 squared. We don't forget to multiply by sine phi, because I'm looking for this leg of the triangle, sine phi and iy. So x component is positive and y component is negative for F3. So what is cosine phi and what is sine phi? We need to express sine phi and cosine phi in terms of what is given. Cosine phi. Cosine phi, I will use this blue right triangle to find cosine phi. It is adjacent leg, which is x3 minus x2. x3, let me use different color. Cosine phi is equal to x3 minus x2 divided by x3 minus x2 divided by hypotenuse, which is x3 minus x2 squared plus y2 minus y3 squared, square root, this is hypotenuse, square root, correct this, 2 is still here, and then sine, then I have sine phi. For sine phi, I will have opposite leg, which is y2 minus y3, y2 minus y3, divided by hypotenuse, which is x3 minus x2 squared, x3 minus x2 squared, plus y2 minus y3, y2 minus y3 squared. Now we know both angles, and we bring these expressions for angles back into F3, and this will be our final expression for F3. F3 as a vector is k q2 q3, k q2 q3 divided by x3 minus x2 squared, x3 minus x2 squared, plus y2 minus y3 squared, plus y2 minus y3 squared. We are right here, times cosine phi, which is x3 minus x2, x3 minus x2, and then I have another x3 minus x2 squared plus y2 minus y3 squared, square root, which brings this expression to 3/2. And we don't forget ix minus y component is negative, k q2 q3, k q2 q3 divided by x3 minus x2, x3 minus x2 squared, then plus y2 minus y3, y2 minus y3 squared, and all this I need to multiply by sine phi, which means y2 y2 minus y3 in numerator, and then denominator will be 2/3, and this is my y component of the resultant. I need to add iy. Iy is here. So all we need to do now, we need to add f1 and f3 as vectors. I need to erase. Force, net force exerted on Q2 is vector sum of F1 and F3, which means that we need to add x components, F1x and F3x, and this will be Ix, x component of the resultant, and then we add y components, F1y plus F3y, and this will be Iy. So let's do it. F1x is right here, so we will have k, and then q1, q2, q1, q2, x2 divided by x2 squared plus y2 minus y1 squared, all this 3/2, then plus x component of f3, which is k, q2 q3, then x3 minus x2 divided by x3 minus x2 squared plus y2 minus y3 squared and 3/2. So we added x components, and this is Ix. We are done with x component. Now we add y components. Y component of F1 is right here. It is k q1 q2 times y2 minus y1 divided by x2 squared plus y2 minus y1 squared to 3/2 squared to 3/2, and then y component of F3 is negative, so I put minus, and then k q2 q3 y2 minus y3 divided by x3 minus x2 squared plus y2 minus y3 squared, and then all this to 3/2. This is y component of the resultant. We don't forget to put Iy here. So we found net x component of the resultant. We found net y component. We solved the problem. We found the net force exerted on charge Q2 by two charges Q1 and charge minus Q3.